Hello and welcome again. This is Mr. Juma. Welcome to lesson 11, still under electrochemistry. So we are discussing lesson 10, factors which influence preferential discharge. So the first factor that we know is the position of the ion in the electrochemical series. So this is the electrochemical series that we are referring to for the cations and for the anions. So similarly here we have for the cations, the one at the top is more reactive. So that means this one not easily. So just going down, downwards, this one will be not easily discharged. But as you move downwards, so the one at the bottom easily discharged. Just as it is the case for the cations, so is the case for the anions. The second factor, concentration. How does concentration affect the preferential discharge of ions? Now, the ions that are in higher concentration are preferentially discharged. So that means that is those that have higher concentration are the ones that are discharged. But if only they are close to each other in the electrochemical series. Now the question is, how close is close? That is still an ongoing debate. However, from the ongoing here, we can use this for the anions, at least to approximate the closeness. Like for example, look at a gap between chlorine and the chloride ions and the hydroxide ions. These two are affected by concentration. So then we can tentatively say that if the gap between is 2 to 3 elements, they are close together. They are close and they will be affected by concentration. But if there are more than 3 elements in between, then concentration will not affect such preferential discharge of ion. It will not affect which ion to be discharged, which one. So where concentration cannot decide, then we go back to factor number 1. That is the position of the ion in the electrochemical series. So factor 1 will carry the day if concentration will have no effect. That means that if the ions are very far away. So let's look at, for example, now the hydrolysis of concentrated sodium chloride. So in the lesson 10, we looked at the concentration of, the electrolysis of dilute sodium chloride. But now we consider electrolysis of concentrated sodium chloride. So the ions present in the solution, we have sodium ions and nitrogen ions as the cations. The anions, we have chloride ions and hydroxide. So the sodium ions come from the salt, hydrogen ions from the water, because it is a solution. That solution was made using water as the solvent. So when water dissociates, as I illustrated, it gives hydrogen ions and hydroxide. Then the chloride ions also from sodium chloride, so it contains chloride ions. The electrode should be graphite so that it does not affect the two factors. That is the first one we have the position and now the concentration. So it does not interfere. So that we only consider concentration, because the graphite electrode is inert, it is unreactive. So let's see what happens at the cathode and at the anode. So once the circuit is connected as complete, the cations, as usual, they will migrate to the cathode, and then the anions migrate to the anode. So as we said, the cathode is positively charged, the cathode is negatively charged, so it attracts the positive ions. The anode is positively charged, so it attracts the negative ions. So what happens at the cathode? So the cations migrate to the cathode, where hydrogen ions are preferentially discharged, and this time is because of the high tendency to gain electron as compared to sodium. That means less energy is required. So in this case, concentration has no effect on discharge of sodium or hydrogen. That means here we are going with factor number 1, that is the position. So look at the position of sodium and hydrogen. So you can see these two, there are so many elements in between them. We have 1, 2, 3, 4, 5, 6 elements in between. So these ones are very far away. They are not close. So as I said, for close we shall use a range of 2 to 3 elements in between. Those we will consider them close. But more than 3 elements, those elements or those ions will be far away from each other, hence concentration will have no effect. So like in this case, there are 6 elements in between hydrogen and sodium. So that means those ions are very far away from each other. There's no effect of concentration here. So here we will stick with factor number 1, that was the position. So concerning the position, the one lower in the electrochemical series is preferentially discharged because less energy will be required to discharge it or for it to gain electrons. So another observation that we'll see at the cathode, the bubbles of a colorless gas, so the hydrogen ions gain the electrons, liberating hydrogen gas. So this is what is responsible for the bubbles of the colorless gas. While at the anode, we have chloride and hydroxide. This time, so the previous one where it was dilute, we saw the hydroxide was discharged. But in this case, it is the chloride ions that are going to be discharged. Reason being is because you can see the difference, the gap between the chloride and the hydroxide. There are only 2 elements. There are 2 elements in between them. So in this case, these ones will be affected by concentration, and the one that is higher in concentration is what is going to be discharged. So chloride ions are preferentially discharged due to their relatively high concentration. So the observation that you will see a vapor of green gas evolved. That green gas is chlorine gas being liberated. The equation for the reaction is that. So this is how concentration can affect. Now this to mean that with the time, the concentration of chloride ions is going to decrease. So once chloride ions concentration will decrease, then hydroxide ions will be liberated. So after some time, oxygen gas will be given out because of discharge of hydroxide ions, as we illustrated in lesson number 10. It will give 2 moles of water and 1 mole of oxygen gas. So that is how concentration affects discharge of ions. Let's look at the third factor, which is the position, which is the nature of the electrodes. So if you use inert electrodes like graphite and diamond or even platinum, they do not affect the type of ions to be discharged. And that's why in the first factor and the second, that is the position of the ion, the electrochemical series, and then we discussed the concentration. We were using inert because they will not have effect on which ions to be discharged. However, and the reason is because they are inert, meaning they are unreactive, so they will not react with the electrolyte. However, when you use active electrodes, there is a big effect, particularly at the anode. It will affect the ions that are to be discharged, so it will dissolve in the solution, forming ions to replace those ions that are being discharged at the cathode. So the reaction usually at the anode, you have that metal rod, it goes into solution, forming ions to replace those that have been discharged. While at the cathode, the mass increases because the ions from the solution gain electrons and become the atoms on the cathode. The reaction at the cathode will be this one, where you have the ions from the solution, they gain electrons, then they are deposited as the solid. Now the best way to illustrate that point is we'll look at two examples, and it will be the electrolysis of copper 2 sulfate solution using one graphite electrodes. So these are inert, graphite electrodes are inert. And then we are going to look at the same, but this time round we are going to change the type of electrodes. Instead of using graphite, we are going to use active electrodes in this case because we have copper. So we use copper electrodes, which now we act as the active. So in this case, let's look at the inert. If we are to use the inert, let's analyze the ions present in this solution, copper 2 sulfate solution. The ions present, we have copper 2 ions, which are coming from copper 2 sulfate solution, they contain copper ions. We have the hydrogen ions, which come from water, as I've been explaining. When water dissociates, it forms hydrogen ions and hydroxide ions. So these are the ions that are formed from water upon dissociation. So the hydrogen ions come from water, and then the hydroxide also from water. Sulfate ions from the salt, copper 2 sulfate. So what will be observed at the cathode? So at the cathode, copper ions are discharged because they are low in the electrochemical series, so I shouldn't just grab that. But you have been looking at it, copper is below hydrogen in the reactivity series, so it is the same as the electrochemical series. It is also lower than it is below hydrogen. So in this case, copper is discharged, so the cathode copper ions gain electrons to form copper solid. At the anode, hydroxide ions are discharged because less energy is required for their discharge, of which I have stated that these ions listed here, they are never discharged, or they are not easily discharged because a lot of energy will be required for their discharge. So what you will observe at the anode, there will be bubbles of a colorless gas which will be evolved, which will be formed, and the gas produced is oxygen gas from this reaction. So the hydroxide ions lose electrons, forming 2 moles of water for oxygen. So these are the electrons that are lost or that are liberated at the anode. Now let's consider, what if we were to use active electrode? What will be the case? So by comparison, now if we use active electrode, so example 2, example 1, we use inert electrodes, but in example 2, we are using active electrodes. So same ions, so the ions present, the cations we have copper ions, hydrogen ions, then anions we have sulfate ions and hydroxide ions. So as usual, the cations will move to the cathode, just as is the case here. Cations to the cathode, then anions to the anode. So it is the same case here, anions to the anode. Now, here the reaction is just the same as this one here. The cathode is not affected. So similarly, just like here in comparison, copper ions are discharged for the same reason. They are lower in the electrochemical series, below hydrogen. So less energy is required to discharge copper ions compared to hydrogen. The mass of the cathode increases because copper is deposited, so there you see brown solid added there is increase in mass. The equation for the reaction which is the same. So the difference comes here. The difference is at the anode. So you see here, when we use inert electrodes, we saw that the hydroxide ions are discharged. But here, when we use active electrodes at the anode, the hydroxide ions are not discharged. So neither sulfate nor hydroxide is discharged. So none of this is discharged. hydroxide not discharge, sulfate not discharge. But instead, the copper rod dissolves. You can also say it is ionized, or it is oxidized to replace the copper ions that are being discharged here. So these ions that are coming out of the solution, they are replaced back. So the anode dissolves, forming back the copper 2 ions. So this will be aqueous ions that are being discharged the anode. Then another very important thing that you will observe is this. When you use inert electrode, the color of the solution fades. So copper 2 sulfate is blue, as I'm going to illustrate shortly. And then, so the solution, the color of the solution will fade. Reason being, the copper ions from the solution that are being discharged at the cathode, these ions that are coming out of the solution are not replaced. But when we use active electrode, you can see that the color of the solution persists. The intensity will remain the way it was from the start of the reaction. And the reason being is that the copper ions that are discharged here they are replaced. You can see here they are replaced, but here they were not replaced. So this marks the main differences when we use active electrode and inert. And this brings out the differences or the effect of the nature of electrodes. So this was the third factor. So we have the three factors that influence preferential discharge of ions: the position of the ion, the electrochemical series, the concentration, and finally the nature of the electrons, which is this. Now I have set up here an experiment for the two, which we will make the observation. We will just compare this in our next lesson, which will be in lesson number 12. We will make the observation of this. So I have set up two experiments, that is electrolysis of copper 2 sulfate solution. Now, in one experiment, we are going to use graphite as the electrodes. Then, in the second experiment, we are going to use the copper rods as the electrodes, and then we give it some time. So this requires almost an overnight, minimum 12 hours. And then we will make the observation. The longer we give it time, the better the observations will be. So let me just show you the setup. So over here is the setup for the two experiments. So in this first setup, so this one over here, so this is copper 2 sulfate solution, as well as this over here. This is copper 2 sulfate solution. So have here two beakers containing copper 2 sulfate. And then, so in this first one, this one, so I'll use the graphite electrode. So this is graphite. So the one that I've connected to the black clip will be connected to the negative side of the cell. So here I have the cells. So you can see the one here. So the one usually with the spring is the negative side, which is the black wire. And then over this side, the pointed part from the electrochemical cell, so that is the positive side. So that positive side, you can see even the sign indicated there, here. This is the positive side. So the red wire, so this wire here, it is connected so from here, so you have flow, the current will flow this direction to the red wire. So the red wire is going through the voltmeter. On the positive terminal, I'm connecting it through the voltmeter, so that when, to help us to see if the current is flowing, if our setup is correct. So, and then that positive wire, so it will have also the other side, we will also have the graphite rod. So you can see this one is connected to the red peg. So I have two pegs here, or the crocodile clips. So you see there is one black, you can see black and red. So I'm going to put them inside the solution here, copper 2 solution, which is our now electrolyte. So this is basically how to set up electrolysis. So first I'm going to place that red one and then see what happens on the voltmeter. So you can see the voltmeter reading there is 0. So but once I place it inside the solution, you can see there is a deflection. So I'll make sure those two are not touching, then leave that setup like that. So the reading on the voltmeter confirms the connection is okay. So that is one setup in which we are using graphite. So in the next lesson we will make the observation to see what has happened. That is in lesson number 12, what has happened in that. So this setup will give it about 12 hours. And then this other setup, so here I have copper wire which I have wound it to form the rod, which is connected to the black crocodile clip. And then also I have the red, so the red as well. So red is for positive and then black is the negative terminal. So the one that is connected to the negative terminal is black, so therefore the negative is the cathode. So this is our cathode. So I'm going to place it inside the solution there. So I'll put it inside the solution, and also this one. So you can see the voltmeter, there is no reading, but immediately I place this in solution, you can see there is deflection on the voltmeter. So this one also, and then leave those the ones that have the rods or the wires. And then so over here, this is the setup for where we have the active electrodes, and then over here this is the one with inert. So this is for the inert electrodes, so they should not touch. So just to make sure the electrodes are not touching, like that also here. So we leave it, and then in the next lesson number 12 we will see what will have happened. Thank you for watching. Don't miss out on lesson 12 of electrochemistry, that is electrolysis, plus the other lessons that I have done on different topics. Please subscribe to my channel for those who are using the YouTube to get these lessons. And for my candidates, I wish you all the best. We will meet soon once everything returns to normalcy. All the best.